Hi, you guys. I have had a couple of questions from quite a few of you about your test. So I just wanted to take a second and do some example problems of ones that a few of you have been struggling with. So this one right here, when it says solve for x, that means that you need to get the x all by itself. Okay, so whenever you're solving for a variable, that means you need to isolate that variable. So in order to get this x right here all by itself, the thing that we need to get rid of is the addition of y, okay, right here. And so remember, when you're solving an equation, the way that you get rid of something is you use inverse operations. So if we want the x to be all alone and we have to get rid of the addition of y, the way we're going to do that is we're going to subtract y. And remember that whenever you solve an equation, if you do something on one side of the equation, you have to do the exact same thing on the other side. So this becomes x is equal to 15 minus y, and that would be your solution. Okay, and if you wanted to rewrite this as negative y plus 15, you could also do that. Remember, if there's a subtraction sign in front of a term, that means that that term is negative. Okay, so the coefficient of this y is really -1. So that is an example of your question number 7. I know my numbers and variables are not exactly the same, but you should see something similar for your question 7. Okay, question number 11. Find an ordered pair that is a solution to the equation. Now, if an ordered pair is a solution to the equation, that means when you plug in the x and the y in for the x and the y in this equation, it will make this equation true. Okay, the best way to do this is to take this equation and to solve for the y. So to get the y alone, we have to get rid of the 5x. To get rid of the 5x, we have to do a subtract 5x, which means I also have to subtract 5x from the other side, which is going to leave me with y equals 7 minus 5x. Now, if I want to find an ordered pair that's going to be a solution to this equation, one thing that I can do is I can set up a table of values and I can pick whatever I want x to be and then figure out what that's going to force the y to be. Okay, so if I take this equation and instead of the x, I let the x be a 0, 5 times 0 is 0, and 7 minus 0 is 7, that means the y is going to be 7. And you guys can see that if I take this equation and I plug in 0 for x and 7 for y, that's going to make this equation true. 5 times 0 plus 7 equals 7. Okay. You could also pick something different for x. Let's say we pick, okay, so you could pick a 1 for x. And if you pick a 1 for x, y equals 7 minus 5 times 1. That means your y is going to be equal to 2. Okay, so 1, 2. That would be an ordered pair that is a different ordered pair that is also a solution for this equation. Because if we plug 1 in for the x and 2 in for the y, it does make the equation true. Okay, you could pick anything that you want for the x, plug it into your equation, and figure out what the y will be when you choose that value for x. Okay, so that's how you do those ones. On these ones, when it says graph the line, there is actually 2 different ways that I showed you to do this. One way is to set up a table of values, find some ordered pairs that are on this line, and then graph the line. Okay, so if you're going to do that, let's say we let the x be 0 in this equation right here. Okay, so if I let the x be 0, that means y is going to be equal to negative 1/5 times by 0 plus 2. Negative 1/5 times 0 is 0. 0 plus 2 is 2. Okay, so this gives me an ordered pair 0, 2 that is on this line. Okay. Let's say I'm actually going to pick a 5 for the x, just because I want my y to be a whole number. And if I plug in 5 for my x, I'm going to end up with -1/5. Sorry, hold on. Sorry, I wanted to just erase that so I could write this more clearly. So I'm going to end up with -1/5 times by 5 plus 2. And then when I multiply the -1/5 times 5, I'm going to get a -1. Okay, that's why I picked a 5 here, so that this would be a -1, and then -1 plus 2 would be a 1. Okay, so 5, 1. That is another ordered pair on this line, so 5, 1. Okay, you could pick a -5. So y equals -1/5 times a -5 plus 2. And then a -1/5 times a -5 is going to be a +1. And a +1 plus 2 would be 3. So -5, 3 would be right here. And then once you have 3 points, you can go ahead and just draw your line. I'm going to show you what would happen if you end up with a fraction. So let's say you pick 2 here. So if you have y equals -1/5 times by 2 plus 2, then you're going to get y equals -2/5 plus 2. And if you take 2 and you subtract -2/5, you're going to get 1 3/5 for y. Okay, so 2 and 1 3/5. So if we go to 2 and 1 3/5, we can see that would be right here. And that is still on our line, isn't it? So it's okay if you pick a value for x that ends up giving you a fraction for the y. It'll still work. It just makes it a little bit easier if you pick values for x that will give you whole number values for y. Okay, so here's the line. Okay, so that is one way to graph a line. Okay, you can set up a table of values, you can pick some values for x, plug those into your equation, and then solve for your y, and that gives you some ordered pairs that are on the line. Okay, another way that you can graph a line is you can use what's called slope-intercept form. And this is actually what I feel like the easier way to do this. Okay, if you're going to graph a line using slope-intercept form, you take your equation and you put it into this form. And this equation that you've been given, it's actually already in slope-intercept form. Okay, you can see that the 2, that's what's in place of the b, and you can see that the -1/5, that's what's in place of the m. So that means this line is going to cross the y-axis at 2. Remember, the b is your y-intercept. Okay, so this line is going to cross the y-axis at 2, and we know the slope is -1/5. So after we plot the y-intercept, we use our slope to tell us how to move to plot another point on the line. Okay, and so since your slope is -1/5, after you have plotted your y-intercept, you're going to move down 1 to the right 5. Okay, remember, slope is always a fraction of the rise over the run. Okay, so the top number of the fraction tells you how many you're going to move up or down, and the bottom number of your fraction tells you how many you're going to move to the right or the left. This has you move down, and then this has you move to the left. Okay, so we plot the y-intercept, this line crosses the y-axis at 2, and then the slope is down 1, right? Down 1 to the right 5. So down 1 to the right 5. So we move down 1 and then 1, 2, 3, 4, 5. Okay, and you can see that this is the exact same equation that we used on the one where we used a table of values to graph the line. And you can see that for both of these, the line ends up being the exact same line. So both methods work. Like I said, I think that using slope-intercept form is the easiest way to do this. And as you guys move forward into your 8th grade math class, you're going to see a lot more of graphing a line using slope-intercept. Okay, now these types of questions are the ones that I have had the most emails about. So I'm going to show you two of these. This says the equation of a line is given below. Find the slope and y-intercept, then use them to graph the line. Okay, so on these ones, you've been given an equation of a line, but the equation is not in slope-intercept form. It's in a form called standard form, which you're going to learn about next year. But the very first thing that you need to do with these is you need to take the equation that you've been given, negative 8 times x plus 2y equals negative 4, and you need to put it into slope-intercept form. So that means you want to solve for the y, okay? You want to get this y all by itself. So let's do that first. In order to get this y by itself, you first need to get rid of the negative 8x term on the left side. So we're going to add 8x. We're going to do that to both sides. And that's going to leave us with 2 times y equals negative 4 plus 8x. And then from there, to get rid of the multiplication of 2, we're going to divide by 2, and we have to do that on everything. So y equals negative 2 plus 4x. Now, this is almost in slope-intercept form, but notice that in slope-intercept form, it's written so that the term with the x is written first, and then the constant term is written second. So if we just switch this around and write it as 4x minus 2 instead, or we could say plus a negative 2, either way. Now our equation is in slope-intercept form. And once the equation is in slope-intercept form, you can then identify the slope and the y-intercept. So remember your slope, that's the one that's in place of the m in your equation. And the y-intercept, that's the one that is in place of the b in your equation. So for this particular example, the slope would be 4, and the y-intercept is a negative 2. And then the last step of this, I believe, was to graph the line. So you would first plot the y-intercept of negative 2, and then if your slope is a 4, remember slope always needs to be a fraction of the rise over the run. So you would actually write this as 4 over 1. So from your y-intercept of negative 2, you would move up 4 to the right 1. So 1, 2, 3, 4 to the right 1. Okay, voila. Okay, so I'm going to show you another one like this. The equation of a line is given below. Find the slope and the y-intercept, then use them to graph the line. Okay, so the first step is to take this equation and to put it into slope-intercept form, because once the equation is in slope-intercept form, then we can identify the slope and the y-intercept. Okay, so to put this equation into slope-intercept form, we are going to solve for the y. Okay, so to do that, we're going to subtract 3x from both sides, which is then going to leave us with negative 2 times y equals 6 minus 3x. And then we're going to divide by negative 2 on everything, which is going to give us y equals negative 3 plus positive 3 over 2x. The negative divided by negative is a positive. And then our last step is to take and rewrite this so that the x term comes before the constant term. Okay. Now, once your equation is in slope-intercept form, it's easy to identify the slope. That would be the one that's in front of the x. That's the coefficient of the x. That's your slope. And then the y-intercept, okay, that is this constant term right here. So our slope is 3 over 2, and our y-intercept is a -3, and now we can graph. So we plot the y-intercept of -3 first, and then from there we go up 3, 1, 2, 3 to the right 2. Okay, remember your slope is always a fraction of the rise over the run. So we have to move up 3 to the right 2. The top number of your slope always tells you how many move up or down, and the bottom number tells you how many move to the right or to the left. And from there, once you have your 2 points, you can graph your line. Okay, now back at this step right here, if you were to have left your slope as -3 over -2, you can see from the y-intercept here of -3, if you move down 3, 1, 2, 3, and to the right 2, that still puts you on the same line. Okay, so a -3 over a -2 is the same slope as a +3 over a +2. So I hope this was helpful. If you have any other questions, please don't hesitate to email me. Thanks, guys.